Well, thank you for the very warm welcome. So we've had an awesome day right now. So we've seen lots and lots of talks. Sadly, I just saw half of it because, much like Hubert, I'm also not feeling at my best health-wise. But we heard about property-based testing. We heard a lot about like distributed systems, and it's all like these cool things. And like it's like, yay, that's cool stuff. Like so, like who wants to go out and build like their next system in Elixir and Erlang now? For a moment, I was shocked, like nobody reckoned. It was like, oh my God, this was a disaster, what the hell? Okay, thanks for raising it. So I imagine that's how a lot of us feel right now. And just to get another, like, who actively is right now already building systems in Elixir and Erlang? Oh, also quite some people, very cool. So these conferences, often like Dave Tomic says, it's like when you watch dog ads on TV, by the end you're convinced you have all the symptoms and you need all the remedies, you know? Like right now after the GraphQL talk, you go like, oh my God, my REST API is so outdated. Like who needs this? Like GraphQL all the way, come on. So usually what we do now, like we go home, we have a weekend, we're super motivated, we go back to work on Monday and then we go like, yes, we write all the apps. That's just like, yes, we need to do this. And well, you can't. You know, like there's business value to them and you can't just, you know, go out, replace everything. That's not how this works. And I would also argue that you shouldn't do that because there's multiple reasons. But first of all these apps have value and just blindly rewriting all of them isn't necessarily going to make them better. Sometimes it's going to make them worse. And actually a lot of times, but those stories are never told. We always just tell the stories like, hey, you know, we rewrote this app and it's so much better now. Very few people tell you the story of we rewrote this app, and after 1.5 years without progress, scratch that. You know, we're sticking with the old app. Nobody tells these stories, usually. So this talk is titled Elixir, Monolith, and You. I'm already did a fantastic job of introducing myself, but you can find me as @Practop on Twitter, and I'm the tech lead at Liefery. And fun fact, we rent office space from BitCrowd. So this part of the office is where we usually sit. So my desk is usually over there, right where my house sits right now. So it is sort of like a home court, home field advantage for me. So usually lots of people that come to Elixir come from the Ruby world because, like, I mean, Jose moved over and like we usually know Jose from lots of things and we trust him. And in the Ruby world, lots of people write what is commonly known as the monolith. It's like your big ass, you know, Rails application. That's what you have. That's your monolith. And like there's people that say like monoliths are bad. I'm not saying monoliths are all bad, but you know, how did a monolith start out? It starts out as this really tiny Rails application that is really, really cute and eats much, much more than it can handle, if my computer can't handle it so well, apparently. But just believe me, she's eating it and she's very cute. And so that's great. You have this feeling like, wow, this is like great. Like, let's go conquer the world with my monolith now. But you know, time goes on, and all of a sudden, it's not your cute little, very agile, flexible monolith anymore, but it's a slow, big, fat pig, you know? It takes ages to about get anything done, to just change anything. It's really, really frustrating, and you look at it like, you used to be so cute, what happened to you, you know? And it's even worse than that, you know? One of the favorite metaphors that I could come up for a monolith is a maze, actually. So it's like this old ancient thing that, you know, maybe some people have traveled in there already before, but there's all these ancient rooms where you don't know what's in there. Like nobody has been there in a decade or something. Like what's happening there? And like you don't know. And somebody just tells you stories like, oh, don't go that direction. That's like really not the nicest part, you know? There's some traps in there, you know? It's like, it's dangerous to venture alone. Sometimes you find the occasional treasure and, you know, you'll be very happy, like, oh, this really is so good. And then, but like, how do I get back out of here to where I actually want to be again, you know? There's monsters, everything is in there. So it can be quite tough. And also that's where I think a lot of like the frustration with monoliths comes from. Yeah. So usually what people want to do is like, hey, just tear it all down and rewrite it. It's going to be that much better. So this is usually what people want to do with the monolith because they're just frustrated. They don't want to do it anymore. And also monoliths are like with old technology, like, you know, this old technology Ruby or like this old PostgreSQL. These also old. Let's do fancy stuff. So how I usually see this happening is that like, this is your monolith, this is your old existing house, and then like you try to build something new, which is totally incomplete, nobody can use it, but you go like, soon we'll have it, soon we'll be there, we'll be great. That's the best thing. And I told you about these stories before, like we have those in the Elixir world, we have those in the Clojure world and all the worlds. It just says like, we rewrote all in language X, and now it's 10 times faster and only 50% of the code, like best thing we ever did, like language Y, so the other language, totally sucks, you know, like, but this new language makes everything better. It's like a silver bullet, makes everything better. And sadly, this often also implies this, like it says that not only like our rewrite did do this, but language X is that much better and stuff than language Y. As I was hinting to before, nobody tells you, few people tell you about their failed attempts. Like when I first gave this talk at the Elixir user group Berlin, like some people came up to me afterwards and was like, hey man, thank you for the talk. Like we had a rewrite story like this. It was a total disaster. Project was canceled after a year, no progress, nothing. It was totally horrendous. But where are these people giving talks? Like I want to see those people give talks about it because that's where we can learn something from. And also, what I want to tell you right now, like I'm not saying like you should never rewrite, but like only very specific cases is it really useful. Because what these stories also leave out is like, if I rewrote my current system, that is Ruby on Rails, my monolith, if I rewrote it in Ruby on Rails again, like it would be much faster, it would be much less code, because right now I have all the knowledge that I didn't have at that time, because you know I build it iteratively. First I think I'm going to do like signal shipments, and then I do this really completely other thing. And like my design needs to move around that. I need to change my design, and I also know where my bottlenecks are, so I can spend like an extra amount of effort on performance on that part and be like much better. And so it might not be 10 times faster, but it might still be 5 times faster, and might still suffice. And also the question is, I mean, I know we're at a programmer conference, but where's the business value, you know? What value do I generate for the customer by rewriting my whole application? None, 0. I mean, you can say maybe in the end, if it then supports some extra features, maybe, but you first got to get there. And also the other question is like, maybe it's faster, but is that really worth 2 years of development? Is it? So the other thing is, while you build your brilliant new house that everybody wants to work on, that's just the greatest house ever, the old house rots, somebody needs to maintain it, and like it has bugs, but nobody wants to fix them because soon we're going to have the new application. And it's often a lie. So we can do better than this. We can try to replace our application step by step. So again, like old monolith and new house. So instead what we can say like, okay, in our new house we already have a bedroom. You can use the bedroom here. But for the bedroom, please go over to the legacy application. There you can use that. So in that way we can sort of like one feature after another, we can build up a new application that everybody uses, but the old application, you know, still remains relevant for the parts that we need it for. How can we do that? We can use it with Terraform, which is sort of unluckily named because it's not like this platform management system, but it's actually an Elixir library that I think was developed at Netflix, if I recall correctly. So it allows you to incrementally transform an older API into one powered by Phoenix, one endpoint at a time. So yes, not the infrastructure as a code thing. And so that is sort of how Terraform looks like. It just sort of looks like a router, so it uses plug router, obviously, and we can say that, like, for get version 1, hello world, we send a response that is our Phoenix application, so everything at first goes to the Phoenix application, and otherwise we have a client. So for the API of our old system, we get the data from there, and then we get the response, and we just send the response to the client, so we're sort of like a proxy in between. So that's already good, but it's not as easy to pull off when you have like a UI. If you have an API, you can do this, and this is a great way to do it, I believe. But it's not so easy, for instance, if you have a UI that you need to take care of. Something else that we can do, and I see people do and see lots of blog posts about, which is also a very efficient and good way, is to replace a critical component. So let's say in our house, it's cold, like it's freezing outside, you know, you're not used to that anymore because it's 20 degrees at the end of October. But you know, the heater always breaks down when it's cold, and it's like, ah, damn, like we need to get a new heater and make a better heater. And sometimes You just don't have the resources to do that. So what you can do is you're going to take that critical component, let's say the heater right now, you can extract it and you build this huge new heater, but like in a new technology that just is better at heating. And thereby replace the critical component, have a new component take over the world, and so you can take the part where it really matters, where you can really take the advantage of, for instance, Elixir. Let's say you want to process lots of data in parallel. That's better done in Elixir than like in PHP, Ruby, or lots of other languages. So that's one way. And I think that's also a way that like lots of people are aware about. There's quite some blog posts about that. But I want to throw a new way to do, well, not a new way, but like a way that I think is often overlooked. I just want to throw it in there. And that is like writing a new component. So again, we're in our house and we're thinking like, well, I would really like a new entertainment system. You know, I just got the Switch, Mario Party came out. I really want to play that with all the people, but there's no space in the house for that. Like, what do we do? And, you know, we could, of course, like try to, you know, build something up here, cram it in there. And, you know, that's how a lot of these monoliths evolve, you know, like this really shouldn't be in here, but come on, let's do it in there. And then like it gets this like monster with like 11 legs or something. So what instead we can do, we build like an entirely new house, I would say, like a tiny house. And then we build our whole new entertainment system in there. And just one thing before somebody shouts at me, this is really obvious in microservices. So if you're doing microservices, it's obvious that, you know, I have a new business requirement, I want to do something new. I probably want to do this in a new application, a new microservice, or in 10 new microservices, depending how micro you go. And I don't really see this question being asked or like this even brought up as a possibility as much when you already have sort of an existing monolith. And so this is what I want to talk to you about. Because what I would really like every developer to do is whenever you get like a new, bigger requirement or something, then you ask yourself, is the technology I'm choosing the right fit for the problem I'm trying to solve? And when the answer is no, then, you know, maybe do it in some other technology, no matter if you have a monolith or not, or at least say what's going on there. What do we need to make this work? So first, we need a reasonably separate and limited problem. You don't want to start out too big, you know, you don't want to have like your second big business opportunity, and it's going to be an application that takes you a year to write. You don't want to go off and write that in a new technology right away. I mean, you can, but there's chances that, you know, actually when you really apply it, you don't like the technology that much. And also, you know, you have to learn about the new technology. And then if you build a giant project, that's like way to dig a hole for yourself, because then you need to learn about it all, and you just shovel away, your estimates run over tremendously, and everything is a huge disaster. So if you have a small, limited problem, at least for the first try, that's very, very good. Another good thing, as I mentioned before, is that if you have a requirement that poses a problem for the current stack, so that you don't just do like, okay, we're going to build this in Elixir because, you know? It's better to have a better motivation, both to convince the stakeholders, but also, you know, to really be certain that you make the right choice. And of course, in the end, you need a spark of enthusiasm. You can't just have like some, I don't know, some CTO or some project member saying like, oh yeah, let's build this in Haskell. And then nobody else wants to do it in Haskell, you know? Like, that won't work. So you need to have like a team that is behind that decision and that is actually enthusiastic about it. So, as I said, I'm tech lead at Liefery, and I'm going to talk about Liefery, not because I want to sell Liefery to all of you, but because now we're going to go through examples that we did at Liefery, and for that you're going to understand at least a little bit what we're doing. So we're a same-day delivery company. We deliver in the name of others, for instance, Zalando and HelloFresh, which means they give us packages, we plan tours, and then we deliver things. So generally, that's what we do. That's what we're paid for. One thing that we want to have for that is courier tracking. What's courier tracking? It would be very good for us to know where couriers are at one point in time. Why do we want to know that? Because then we want to know, are couriers late? Where are couriers? What are they doing? Because otherwise, you know, our OCC, Operational Control Center, always has to call and be like, hey, where are you? Why is this package not delivered yet? And then it's like, oh, well, you know, I don't have data on my phone anymore, so I can't transmit it to you. Or like, I'm actually stuck in traffic or something. If we could just see them on the map, huge advantage for us to see what's going on. So this is sort of what this looks like. So this is a map. This is the current position of the courier that is live updated in the backend. And here you can sort of see where the courier went versus an approximation or where we said the courier should go, more or less. So that's a reasonably separate and limited problem. It's not huge, but it's not small. Also, it poses a problem for current stack. As I said, like our monolith is a Rails application, and really no matter what David Heinemeier Hansen and what's it called, Action Cable, no matter what they tell you, Ruby is not the platform to build highly concurrent systems and WebSocket systems. It just isn't. Like when you look at the performance comparisons, like they can maybe handle 100 clients. In Phoenix, we can handle 2 million clients, no problem. So it's just not a good system to build that on. It's just not a good technology for that. And what did we have? As well as the spark of enthusiasm, as I called it, we already had some basic knowledge. Namely, a colleague and I had been playing with Elixir before. Mind you, this was, I think, 2015 or something. Man, I've been doing this. Or was it 2016? I'm not quite sure. No, I think 2016. I should have checked up on the dates before. But yeah, so it was a time before. I think I already wrote the first version of Bench. Did I write it up? OK, I shouldn't talk about dates that I don't have in mind. So we said, like, OK, Elixir, we looked at other technologies, but we said, like, OK, Elixir might be a good solution for this problem. But now we need to figure out, like, OK, we have this other application here. And then your question is, how do I get data from one application into the other application? How do I make those applications talk to each other? So this is sort of what we had. We have the Rails monolith, which has its own Postgres database. We have the front end, which is part of the monolith, but because it's like separate, because it's a JavaScript code and everything, I painted separately. And then we have the courier application. This is an Android application currently written in Scala that the couriers have with which they do the deliveries, where they say, like, OK, drop this package off on something. And obviously, our GPS data has to come from the courier application. Hence, it's important here. So now we want to introduce a new application, which I call the tracking application, which is in wonderful Elixir purple. And of course, because we want to separate the databases, like never have 2 applications on the same database if you can avoid it, please. So how can we connect them? So we looked at this, and we figured out, like the only clients that we have that are really interested in the tracking data are the courier application and the front end. So the courier application just needs to push the GPS data, and the front end wants to consume it, show it, everything. Like the monolith itself is not really interested in it. I mean, there's cool features that you could do with it eventually, but we're not doing them right now. So we're like, so they don't actually need to be really connected. So what can we do? So there's this thing called JSON Web Tokens, JWT, which is a standard that basically says, like, I have a header, I have a payload, and I have a signature. What's all this? Well, the only thing that you really got to care about is it's some piece of data that has some sort of signature that says, like, somebody signed this, like cryptographically signing, and this is the data I was given, and it is correct. And that's all we need, because we need to know. So if we go back here, here, we need to know that, like, these are really authenticated with the monolith, and actually they can push the locations that they say. Like, I don't want to have people out there in the internet just going like, hey, I'm this courier and I sent you 1 billion locations. That's not what we want. So what do we put into that JSON Web Token? Everybody has a role. So admin or courier in our case. Then we have the courier IDs that they have access to, their own ID. And also, these tokens have an expiry time, which is usually relatively short, so that if a token gets intercepted, it can't be useful for too long. What we needed to do this, because when you need to have something signed, we need to have some sort of key. So we established a shared secret between the tracking application and the monolith, and that's sort of the only way how they directly work with each other. Then the monolith can issue this JSON Web Token to both the front end, which is then the role admin, and to the courier application, which then is the courier. The front end gets the admin token with the IDs of whatever the couriers are there on the page that I'm currently looking at. If I look at a single shipment, I get the ID of that single courier. And if I look at sort of an overview map, I get the IDs of all the couriers that are currently active. And this courier just gets, their own ID. Then they use this JSON web token to authenticate with the tracking application. And that's how we have a user. And now we're actually going to see some code. So first, in the socket, we need to connect. We take the token. We verify that's a good token. So the cryptographic signature is there. It's not expired, all of that. And then respond based on those token contents. And in the ideal case, then we log in the user. And if you've done Phoenix channels or sockets, you might have seen this. So we say like, OK, this was successful. To our socket, we assign a user, and that user has this role and all of this. And we know that this data is true because it was in a JSON web token. We verified that this data is from like a trustworthy source. Now we want to join the channel. So our Phoenix channel and the WebSocket. And then each channel is courier colon, and then some courier ID. That is the courier for which I want to push notifications or get push locations or get to the locations. And then we just check, is this courier, is this user authorized to see this courier ID. And this is this wonderful little method, by the way. I don't know how many people said it today, but I love pattern matching. Pattern matching is like the best thing. If I had one feature from Elixir to take to like any other language, pattern matching out of the box. OK, so pattern match, is our courier ID an empty string? If yes, then I don't care about anything else, like you don't have access here, because if it's an empty string, like something is clearly wrong. So I have a courier ID, and my user has a list of courier IDs. Then I just check, is within these courier IDs, is the courier ID in there? If yes, then you have access to this channel. No, you don't. And otherwise, no, you don't get access. Pretty simple so far. So most of the time, the interaction just looks like this. The courier location pushes locations to the tracking app, which then gets them from a channel, and then we display them in the front end. This part here is actually WebSocket and channels. This other part, though, it used to be a WebSocket with channels, but there were multiple problems with that. First, when the Phoenix documentation tells you that there is an existing robust Android library or Java library for consuming like the Phoenix channel protocols, don't trust it. It's not very, very good. And also we have problems with the phone, because basically to keep the WebSocket connection, you need to wake up the phone all the time for it to stay open. And then Android is very eager about killing applications that do network all the time. So we needed to switch it to a REST endpoint. And he isn't here right now, but our Android developer was very, very happy about that switch because it made life much, much easier for him. So that was sort of our first case study, which was a very good success. Like it didn't take long to implement. We had all the libraries we needed. It was all there. We had like for Postgres, we had the geographic post. What's it called? PostGeo? No, I forgot it. Postgres. Postgres plugin or whatever it's called, and it already had like Elixir bindings and everything, JWT libraries. Everything was great. So like there was no point where we were like, oh, we're missing like a library for this. And I remind you, this was back like 2.5 years ago when we started this. So this was very, very cool for us. So we had a new problem, and we wanted to try it out. This new problem is fulfillment. So our business model only works if our partners have a warehouse close to our parcel hub, so that because we do same-day delivery, that they can give us the wares on the same day to us, and we can deliver them on the same day. We allow that until like 16 o'clock when we deliver between 19 and 22 o'clock. However, not everybody has a warehouse next to our parcel hubs. So we want to offer a service where we basically get the wares up front. Think about maybe like mobile phones. So give us 300 mobile phones. We have them somewhere. And then whenever you send us an order, we just take one mobile phone, and so we deliver it for you so that the wares are with us so that we can really do same-day delivery. So again, that's a reasonably separate and limited problem. But it's just, well, nobody tells me that I'm standing right in front of all my points. I'm sorry. But it's just a simple CRUD application. You know, there's no real need to do this in Elixir Phoenix. There's nothing too fancy going on. But we had like a very good experience with the last application. Also, everybody was eager to continue, so we were like, okay, let's give this a try, let's give this a shot. And yeah, we already had like the confidence and the experience after the first application. So how does this look like? Right now we just have our fulfillment application and the monolith. So this time it has its own UI. So you have your own UI where you sort of can, at first you need to authenticate. This time we chose OAuth to just be like, okay, give us a token so we can call our API, and then we can ask it, so like, who am I? And then we're authenticated, we have the data about the user, can this user do this, yes or no, or whatnot, and then we can start creating products. What is creating products? So somebody might give us mobile phones, and they might have 3 different mobile phones that are stored with us, or just one, and we say like, okay, this is this product, because they need to reference it later on. So what happens when an order comes in? So we get the order, which basically says us like to this and this address, and they ordered 5 these phones, 3 that phones, and so on. So we get that, and then we check in the monolith like, hey, is this actually valid? Because we need to do a whole bunch of address validation. We have little time to do like manual address corrections because we're same-day delivery. We simply don't have that time. And so we just said, hey, does all of this make sense to you? Because we don't want to duplicate the logic. And then once we're packaging these, so we're saying like, okay, I took 3 phones, put in one package, and then we create a shipment, it's called in our system, and then we take 3 other, package them up, and we create another shipment for it. So that's basically how the interaction works. And those are all HTTP REST calls. Like, we're not fancy, we don't have a GraphQL API, it's all simple REST calls. And now, like, who knows what railway-oriented programming is? Who has heard about railway-oriented programming? Okay. So it's, like, happy for the others, you learned something, hopefully. It's one of my favorite things that when I learned it. And actually, I remember that we started implementing this with a colleague, and I was like, hey man, you could simplify this so much with railway-oriented programming. And he changed it, he was so happy, he was like, man, this is so cool. So maybe I'm overselling it now, but so for this, a pattern started to emerge. Like, okay, first, railway-oriented programming. So this is sort of like a service that we have for order creation. And here we can say this is our success rate. What this basically says is like, okay, I call validate order with my params and my customer. If it returns OK order, continue. Then I call validate in backend, and then I continue, and so on. And if all of this succeeded, one of another, like this is the success rate, you go here, success, 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 okay, then this is my destination. However, if at any point in time, this doesn't return what I pattern match on here, so if it returns error and some change set, then I sort of swoop over to the other lane and then go that other lane, but I ignore the other stuff. So if validate order fails, I don't even attempt the other steps because I know it is already broken. And I just go in here and I give you the error and the change set. And we noticed that this pattern emerged because here pretty much for everything that we did, we needed sort of 2 validation checks. First, there was data that we could validate in our own system without doing a network call to the old monolith. We could say like, okay, if I have an order has product IDs, I could see if we really have all those product IDs. If there's a product ID that I don't have, I can process the order, so I can just error rail out and be like, hey, please send us just product IDs that we know of. After I validated internally, then I validated in backend. Backend is our internal name for the Rails monolith. It's called the backend from way back in the time. So that does the HTTP call that checks if the shipment is valid. And if that also succeeds, then I insert it into the database. And that's when maybe some other validations that now with both pieces of data can trigger, or where our database constraints can bite us. So this is like a very cool pattern that if you have a system that works with another system, it's very easy to follow, I think. And so that's why I really, really love it. Yeah, and if we're done, we just return OK in the order. So yeah, so that fulfillment worked out, let's say, OK-ish. We had more problems with it than we anticipated. So I could tell you that for the courier tracking, everything worked flawlessly. Like we had all the libraries that we needed. But for this one, for instance, Wallaby, sort of like Capybara, like the UI feature-based testing wasn't a big API change, but we wanted to use Wallaby because we think it's much better than Hound, I think the other one is. But so we had to wait for that. And then we wanted to have API documentation because actual customers need to use this new API now. And at the time, the Phoenix Swagger was in some big merge between like a fork and the original one. So all of that delayed it a bit. And later on, we also had, sadly, we haven't worked on this in some time because we're missing like many customers go on it. So if you want to make Liefery developers very happy and you feel like you need the service, go buy the service. We can work on it. You make us very happy. Anyhow, moving on. So one thing that you might ask yourselves right now is like, what's this? You know, you just took Phoenix and you HTTP REST and you put time series data with locations in like a Postgres database. There's no Kafka, no message queue, no GraphQL, no time series database. What are you doing? Like, how lazy are you? You know, like, do like all the cool stuff. You know, what's this? Is this 1995 or what? Like, come get with the times. You know. And I gotta say here, be careful with new technologies. You know, there was already this one big new technology that we introduced, which was Phoenix and Elixir, which was already quite the jump for us. And you know, we thought about like putting like a time series database in there, but then it's like, okay, we don't know Elixir, we don't know the database, so what do we know? You know, you need to learn about something first. And the added danger if you use a new programming language is, of course, I don't think there's a time series database where Elixir has very good bindings for it or very good support. So that's another problem that you need to take into account. So please go one step at a time, because if you just build everything on the newest hipster stack, then you're gonna lose it. So now people might jump and be like, hey, you're just talking about microservices. Like, what the hell? Like, I've been sitting here all the time. It's just microservices. And I prefer to call them macro applications, at least the way we do it. Like, they're much bigger than a microservice, and they also often have their own UI. In microservices, oftentimes they don't even answer the UI question, because then there's still somewhere some monolith that, you know, consumes all the data and is gigantically big. And what we try to do is we have applications that, like at least the second one, has its completely own UI. We can do this because most of our application is for internal use. It's for people with us, so like they're not scared when, you know, suddenly the UI looks a bit different. They're actually happy about that because like the UI of the fulfillment application is much nicer than the backend UI at the moment. But that's different. And also another thing I want to tell you is like this is not just for, you know, introducing new technology to your stack. We have another application that is the white labeling application, which allows our customers to sort of have their own designed tracking pages. And we did that in Rails with a React front end because like this didn't need high throughput. And at the time we had an intern and she already knew Ruby. And so she built a Rails backend for it. And so we didn't want to do that in Phoenix. And so it's not just for doing new stuff, but it's in general a pattern that you can use. And now, of course, this is the end of the talk, and I'm early because all challenges are clearly technical. Obviously, it's not. Like, the technical stuff often is among the easiest when you do this kind of transition or when you try this kind of transition. First, you need stakeholders to convince, you know, especially like, oh, yeah, we're going to write this new application, this new technology, and it might take us longer, but like we think it's very good, or we need to do this. Like, do you really need to do this? Do you just want to, you know, play with something, or what's up? You know, you need to have someone to convince, and that's exactly the point where the previous point about saying that it needs to pose a problem for a current stack is really, really important, because then you can say like, really, if we build this with Rails, like maybe it scales until we have like 100 couriers, but you know, you want to grow, right? You know, when we have 1,000 couriers, it won't work anymore. You know, that's sort of the arguments that you need to get into. But then, you know, when you take longer with something, as we did with fulfillment, then business will come back and be like, hey, why is this taking so long? You'll be like, ah. So yeah. The other part, as also alluded to before, is the team. The team needs to be willing to, you know, do this technological change, willing to go with it. If half of your team doesn't want to do Elixir, like don't shove Elixir down their throats. I don't think that's a good way, because people are just going to be demotivated and not do it at all. But there were other things that we did and we learned that worked quite well for us if we want to do this type of transition. So first major version, how we did it is first, the two of us that already knew Elixir sat together and built sort of the first major version, the first building blocks put in place. Not the UI, but like just to figure out, what do we do? What are our credo rules that we define, for instance? Right now, I would set up the formatter and everything to get all of that right. And to sort of also show people a structure from the photos, something that they can look at, like, this is how things are done here, so that's what I want to do. It's just, some helping steps to help the team move along. So, but then when you do this, and I'm not saying do that for a long amount of time, I think we did it just for 2 weeks or something. It shouldn't be like you just working there for 6 months, you're the cool Elixir people, and everybody else just, does other stuff. No. Get that out as quick as possible, and then you need to get the others on board as soon as possible. The first approach that we tried was workshops. And workshops don't really work that well. You sit there for 2 hours, you go through the whole application, and you explain everything, and everybody nods and be like, this is cool, this is fine, this is great. But nobody understands a thing when they should work on it alone. And so my motto now is like, to know it, you got to build it. So we set up rules after we sort of saw the workshops fail. And that is, we always pair an adopter, so like somebody that now learns Elixir and Phoenix, with an alchemist, although I don't really like the alchemist term, but let's use that for now. And the alchemist does not touch the keyboard. Because also in pair programming, it's so super easy if, the person that knows just takes the keyboard and be like, la, 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 this is what I'm doing. You sit there again, not think like, yes, I understand, then you don't. This is why, the person that needs to learn needs to have control of the keyboard and needs to go on their own pace. Yeah. So this is sort of what we learned. And this is like a common complaint that I got at the time when we wrote this, like, we're still using this like Rails. We should use gen servers. And today you heard a lot about gen servers and distributed system. It all seems very enticing. It's like, oh yeah, I need to do Elixir, I need to do this. And then you'd be like, calm down. Like, but we're not doing anything in parallel, like, blah, 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 blah. And they say, hey, like in Phoenix, every channel already runs it in its own process, its own gen server. Every HTTP request is in its own process, its own gen server. Actor already has a pool with lots of processes. It's all there. Like the infrastructure is all there. Like, good people wrote those and gave it to you. Like, it all just works, You don't have to do anything special. And in that sense, we're still using that like Rails. It's sort of a compliment I thought about. Because, you write it just like Rails, but it's that much more parallel and that much more efficient and fault tolerant. So that is something cool. And what I learned from that is a mistake I think that we did is we didn't give enough time for education. So I read lots of books and stuff in my free time. And I think we should have given that time also on work time to other people. So I can only highly recommend the Programming Phoenix book. I think a beta update for 1.4 is out and like will soon be 1.4 and above. Brilliant book because like also the authors Chris McCord, Bruce Tate, José Valim, those are the people that wrote Elixir and Phoenix, They give you all the insight on, for instance, why we don't do mocking and stubbing in Elixir and what we do differently and how do you do this. So brilliant book to read, lots of fun. Another cool book that when I first wanted to give this talk was just in beta and I was sweating about because I would give a talk about adopting Elixir and then José Valim, Bruce Tate and Ben Marks write a book about adopting Elixir. So I was like, gotta read that, so see that like I don't conflict with them. I was very happy about it because I was long critical about the people that wrote their own gen servers and processes, as I just told you. And there's a whole chapter in it about like where they were at a company and they wrote processes for everything. It just made everything horrible, overly complex, and actually slow because it's also very, very easy to build a bottleneck with those. So I can also highly recommend that book. And I'm also personally very happy that it has a chapter about Benchy. So that was a personal accomplishment. So how do I sum up this talk? For all of you who want to go there and like try some new technologies or write some new applications, you don't need to kill your monolith. You can just complement it. And if you do that, soon you will have sort of like a couple of nice little applications that can all call with each other and be nice and well with each other. So enjoy using Elixir effectively to help your company.
Do you want to take questions?
I can take questions.
Do we have any questions?
I just had a small question on railway-oriented programming. So it's a really nice way of kind of doing step by step by step. but I find it's really hard to test because you end up with like 5 or 6 things that you do,
Hmm.
and they can all have their own side effects, and how do you actually test that?
I think it's actually very nice to test because I know that like each step in those and the rail, I know that I need to have like sort of a test that triggers each one of those. You know, each one of those needs to produce at least one failure because otherwise I don't need that step in the rail because like what is it doing otherwise? So it helps me discover the test cases very well, I would say. I mean, you need to write lots of tests, but yeah. But for the HTTP part, it's then you gotta, like, we have sort of configured mock responses that we run in tests so that we don't have to do an actual HTTP request, and sort of we have like a mock client that returns on special values, gives us special fault answers or success answers. If that, okay. We can also, I'm also still available, so we can talk after if you want. Anyone?
Any other questions from anyone? Okay, and that was it. Thank you so much, Tommy.